Hello everyone, welcome back to another session on embedded systems. I hope all of you are doing good. Well, let's begin without much delay. Okay, so we have been discussing the sixth module of EC308 embedded systems, and in our first session we saw what are operating systems, what are real-time operating systems, the service goals and structure of a basic operating system. I hope those concepts are very clear to you because these are very necessary for this session and the coming sessions. Okay, so this session we shall deal about kernel. What is a kernel? You are already familiar with what are kernels from our previous module. Yet we will see in much more detail what are kernel, how is it related to an operating system, and various tasks or services done by the kernel. And in the services done by the kernel, in this session we shall concentrate about process management as well as memory management. So let's start. What is a kernel? The kernel is a very core of the operating system, and in fact it is the responsibility of the kernel to manage system resources and ensure that there is a proper communication between the hardware and the system services. I hope you remember what is an operating system. An operating system basically provides an interface between the user and the system hardwares. So in fact it is the kernel who is responsible for a major part of operation of this operating system. The kernel makes sure that there is proper resource allocation and there is proper communication among the hardware and other system services. Thus we can say that the kernel acts as an abstraction layer or an interface layer between the system resources and your user applications. I guess we have discussed this in the previous module itself, if you remember the with figure. Yeah. So this kernel consists of a number of system library and services which is purely designed for resource allocation and communication. And a general purpose operating system, the kernel has a number of services such as process management, primary memory management, file system management, input-output system or device management, secondary storage management, protection system, as well as interrupt handling. In this session, we shall focus on process management and memory management. Basically the operating system, they has some of these structural units which are kernels with file management and device management, as well as kernel without file management and device management. Now these are a part of kernel in the operating system and any other functions not provided for the kernel, right? So the kernel basically has the memory space. They basically controls the memory space for the functions, data, stacks, and these memory sections are protected from access by any other sections except the system call. I hope you remember what is system call and user call, right? So the system call is generated by the kernel on demand from the operating system. The user call is generated by the user system, right? And this section of memory space, which includes that for functions, data and stack, they are only accessed through a system call. Okay, this we have said this in the previous session too. Now let's see what are the basic kernel functions in a general operating system. They involve process management. So when we say process management, we start from the creation or formation of a process to the deletion of a process, which has a number of stages. This involves the process creation, activation, running, block state, resumption, deactivation, and finally deletion of the process. And this process management is also responsible for maintaining the PCB, the process control block. Another service provided by this kernel is process management and process maintenance. This, as the name indicates, they maintains the process structure and their information which is present in your process control block. The third service is processing resource request. So we know that the kernel is responsible for resource allocation, and this part of process management, the process resource request, they process the request made for various resources, maybe a memory space for input output devices or any other resources which are made either by making messages or by system calls. So system call means it is done by the kernel. Messages or user call means that is done by the user system, right? The process management also involves scheduling. So in the scheduling, we are responsible about which process will be executing first, second, third, based on various priorities as well as time given for each process. The process management section also has various synchronization functions or inter-process communication functions. So this process is synchronized by sending data as messages from one task to another. And as we already know, there are a number of IPC techniques such as signals, semaphore, queues, mailboxes, pipes, sockets. So by using any of these methods, the operating system can effectively manage the shared resources using any of these synchronization methods. And apart from this process management section, the kernel service also includes memory management, where they are responsible for the allocation and deallocation of memory. And they also restrict the memory access region for a task, which is based on whether the memory access is through a system call or a user call. Another service provided by a kernel is file management. So with respect to a file, some common operations that takes place are creation, deletion, read operation, write operation. So all these operations are managed and controlled by the file management section in your kernel. And with respect to an embedded system or any system, the file basically they can be in the RAM, right? So here all the operations related to the files which we mentioned earlier is maintained by the file management section. We also have the device management section where device managers are available. Device managers are available to control the various device drivers, device ISRs, and the resources for these devices. And apart from this basic physical devices, we also have virtual devices such as your pipes and sockets, which we are already familiar with. So these virtual devices, they emulate the hardware device, and the virtual device driver sends the signals similar to the ISR called by the physical device. So this virtual device, pipes and sockets, they work similar to the hardware device itself. They act similar to a hardware device, and this virtual device drivers is responsible for sending signals which are similar to your ISR calls by physical devices, and thereby activating or communicating this virtual device to your system. The kernel also ensures that there are various device driver functions, and these device drivers may be for accessing your keyboard, your display system, disk, network cards, or parallel ports, network devices, virtual devices, whatever be the additional physical devices that you are interfacing. So their use can be facilitated by using these device drivers. Another service which the kernel is responsible for is the input-output management. So they are basically ensure that your input-output ports, whether it be parallel port or a serial port, they are accessible for the system based upon the task which demand the ports. And finally, the final and a very important task of this kernel is the interrupt control mechanism, that is for handling ISRs. And this mechanism of the kernel, they ensure that the interrupts are serviced efficiently. When you say efficiently, we make sure that the high priority interrupts are considered accordingly, the low priorities are even considered, and all the processes, they have a good access to this interrupt and they respond well to this interrupt. So all these sessions are ensured by the interrupt control mechanism. So these are the basic functions or services that your kernel provides, and no doubt, in fact, all these tasks make the operation of an operating system, right? So it is a kernel which is the main part of your operating system, and we have seen the various services for a kernel. Now let's focus on one major service of the kernel, that is the process management. So when it comes to process management, we have various functions such as process creation, managing the created process, and the process manager and things. So we shall see each one in detail. To begin with, process creation. So if the kernel want to manage any process, your first thing is you must need a process. So the first section of your process management is the process creation, which means we need an initial process. Now what is the initial process? See, once you reset your processor in your system, your operating system is first initialized, and then a process which can be called the initial process is created. Initial process means the first process. When is a process the first process? When a processor is reset and your operating system is initialized first, the process which is created is called the initial process. So when I say initialization of operating system, it means you are enabling the use of operating system functions, which includes the function to create the process. So whenever you are creating the first process, that's obviously called the initial process. Then the operating system is started, and then they run as an initial process. And these processes can be created hierarchically, one after the other. And when I say we are starting the operating system, which means that you are calling the operating system functions, which includes calling the created process even before the operating system start, but only after their initialization. So you have initialized the operating system, you have created an initial process, and you are calling the operating system functions to attend the created process. So this process can be created hierarchically, and this initial process can create subsequent process and so on. No doubt we can say that the process is created hierarchically. Once you have a set of process, the operating system schedules the process and provides context switching between the process or threads or both. And when you are creating a process, it means you must specify all the resources which are allocated for the process, the address space for created process, the stack, data, heaps, everything that is associated with the process, even the process control block. So creating a process, it just don't imply that you're just creating a task, a process to be done. It means you must also allocate all the memory blocks, the stack, data, heaps, and even the PCB, the complete information about the process must be specified when you are creating a process. Right? Now, this process manager is also responsible for allocating the PCB when a process is created, and the process manager also manages the PCB. We'll see them in detail. So let's refresh, what does the PCB contain? We have already seen that in the previous section, yet let's see what are the contents in a PCB. The PCB, the process control block, mainly contains the context, the process stack pointer, the current state, whether the process is in a created state, activated, is it running, is it blocked. The current state of the process is stored. The address that are allocated and presently being used, these are stored. The pointers for the parent process, for daughter process, for the resources, everything, all these pointers are stored. And apart from that, we also have the memory buffer for pipe, mailbox, semaphores, and even the process ID. So all these sections are saved in the process control block, or we can simply, the process control block has all the information related to a process. So it is necessary to ensure that during the creation of your process, you also create your PCB and you later maintain it using the process manager. Now, how do you manage the created process? Say now by this time you have your initial process, and this initial process has created other process, and we have a hierarchy of process. How do you manage this process? How can you ensure that a process is in a created state or running or blocking or deleted? So you need some kind of a management system to manage your created processes. That comes under the management of created process by the process manager. Now, this process manager, it's simply a unit of your OS, and they are responsible for the execution, the management, the process creation, activation, running, blocking, deactivation and deletion, resumption of all your process. The process manager is just like any other manager. They are responsible for all the activities of your process. The process manager also ensures that each process, in case of a multiple process, is executed such that the process state can switch from one state to another. Now, what do you mean by process state? I guess you guys are familiar with it. We have the created state, the ready or the active state, and the spawn state, which means the process is created and active. The spawn, a combination of this created and active. We also can understand, another state of the process is the running state, whether the process is being executed, that's the running state. When the process has been paused for maybe due to another interrupt or due to other high priority task, they enter the blocked state or suspended state. And once such an interrupt is over and you retrieve your process, they are in the resumed state. And finally, if your process has finished its execution, they enter the finished state and ready after finish. When there is that happens when there is an infinite loop in a process. So you have executed one execution and you're ready to continue the second execution. So that's ready after finish. Fine. And finally, you have the deleted state of your process. Now see, the blocking and this resuming state. For a process, these two states, they can take several times for long process. And different kinds of operating system, they can make the provisions for possible switching between creation and deletion, different manner. So these are the general states present in a process. It may change, or it may has additional states or less number of states depending on the operating system that you use. Basically, the states are created, active, running, blocked, resumed, finished, and deleted. So these are the very basic states of a process. Now, this process manager, we have this process manager. The process manager will execute the process request for a resource or an operating system service, and then they will grant the request to the processes which shared the resources. See, the management of the process, which is done by the process manager. They can take care of the different states in the process, and they can also handle the request for the resources. Two major tasks. Now, how is the request for your resources handled? We have two methods. One is a message, two the system call. Message, see, we normally use messages, right? Different kinds of text messages, calls, anything. So these messages are related to the user. That is, the messages are process requests created in the user mode, which means they are restricted to some extent. So a process running on user mode generates and puts a message so that the operating system can let the requested resource from maybe from a device or from some other queue, and use this to satisfy the user needs. Now, see here, if you want to access a memory, the user first sends a message to the operating system. The operating system has to authorize the access of these resources. So, in a user mode, accessing the resources is not quite an easy task. It is done through messages and only with the permission of your operating system or kernel. So, the request for resources in a user mode is called messages. So, you can relate messages with users. Us, we are the one who commonly use messages, text messages, different types of messages. Okay. So, messages are related to user mode, resource request for user mode. Okay. Other kinds of request is in the form of system call. So, when I say system call, it is a much privileged form of a resource request, because this call to a function, it is defined at the operating system itself, which means this is some kind of a message request which occurs in, say, the supervisory mode. Yeah. Okay. So, I hope the difference between the message and system call is clear. So, only when a kernel gets a system call, they will access the, they will grant the permission to access a memory. Okay. So, when a message comes, the operating system asks the kernel to generate a system call so that they can access the message. This is a lengthy process. It involves intermediate steps. But in the case of a system call, this is generated at the operating system itself. They do not need any additional permission to access a memory location or something. So, I hope the difference is clear. In user mode and in supervisory mode, lengthier process, a quick execution. Right. Okay. So, I hope the concepts behind process management is clear. And let's see finally what are the major tasks of a process manager. So, the major task of a process manager is that this process manager makes it easy for the process to sequentially execute or block when needing a resource and to resume when it becomes available. So, the process manager assures that there is a sequential execution of a process or blocking of a process when they need a resource, and they ensure that once they get a resource, their operation is resumed. So simply, the final operation of a process is controlled by the resource manager. When a process will execute, when they get a resource, and if they get a resource, they are in execution. So all these things are ensured by the process manager. The process manager also implements the link to the resource manager for resource management. Clear, right? Another thing is that they allocate specific resource sharing between the specified process only. So if two processes need a common resource, that resource is shared between the specific process only, not between other processes too. And this process manager also allocates the resources as per the operating system's resource allocation mechanism, and they manages the overall process and resources for a given system. So in short, the process manager is responsible for the complete resource allocation. All the tasks which are related to the resource allocation of a system, of an operating system, and between process, they are done by the process manager. So I hope the concept behind process management is clear. Process management is one very important service provided by the kernel. So we have seen what are the stages in process management, starting with process creation and later the management of process. To manage the process, we have someone called the process manager, who is responsible for the complete resource allocation to a process. I hope the duties of a kernel and their first important responsibility, the process management, is clear to all of you. If so, let's step on to another important service of kernel, which is the memory management. So as the name indicates, we can see that memory, which is also a resource. This memory management section will deal with how you can allocate and deallocate this memory. That's it. Whom to give the memory first, whom to take the memory from, all these things are controlled by the memory management section. So they basically involve memory allocation. In memory allocation, see, when a process is created, we said that we must know the memory and resources allocated with the process. So here the memory manager, they will allocate the memory address to it by mapping the process address space and all the details related to the process. Right? That stage is called memory allocation. You have a process created and the memory manager will allocate the memory address to that created process. That's it. Now, after initial allocation, how do you further manage the memory? So, basically the memory manager in your operating system has to be very secure, robust and well protected. So there must be some control such that there is no memory leak or stack overflow. Now this memory leak means, there may be an attempt to write into a memory block which is not allowed by a process or something. Which means you have a particular memory area which is not allowed for process 1. But the process 1 tries to give data into that memory block. Such a condition is called memory leak. And there may be issues of stack overflow also. So in stack overflow, see, suppose the size of a stack was say 1 MB. So if the stack size exceeds this allocated memory, that is 1 MB, there is no other provision for additional stack space. So when issues of memory leak and stack overflow comes, there must be some mechanism to control or prevent these two kinds of memory issues. So this memory manager must be well protected and robust to prevent such kinds of attacks. So the memory management basically deals with these tasks. Their main purpose is allocating resources as well as ensuring that your memory system is robust and secure. Well, let's see in detail what are the memory management functions in an operating system kernel. As we have said, one important task is allocation and deallocation of memory. Providing memory to a process, and once the process has completed their execution, retrieving the memory back. That is allocation and deallocation. Another task is the fixed block allocation. See here, if you remember from what we have said earlier, the whole memory address space, they are divided into various blocks, with each process is having small address space, and they get a lesser number of blocks, and the process with bigger address space will get a larger blocks of memory. So we have a fixed block allocation to manage the memory. The process which has smaller address space, obviously they will get lesser number of memory blocks, and those with larger address space will get a larger number of memory blocks, right? Another responsibility of memory management is dynamic block allocation. Previously it was fixed block. Now what may be dynamic blocks? See, initially your whole memory address space is divided into fixed blocks, but later on demand from maybe some process or things, the memory management can allocate variable size blocks dynamically, maybe on demand from a process or any other task. So that is called dynamic block allocation. So the memory management allocates memory blocks of variable size dynamically. This may be from a set of unused or free memory blocks. This dynamic allocation may be from a set of free memory blocks or unused memory blocks. The fourth responsibility of the memory management is the dynamic page allocation. So you know that memory has fixed size block called pages, and the memory management unit, the MMU, they can allocate the pages dynamically with a page descriptor table to various resources. That's what happens in dynamic page allocation. Pages and the page descriptor tables are allotted to various processes. The fifth task is the dynamic data memory allocation. So here the memory manager will allocate memory dynamically to different data structures. See, in fact, all these functions you can elaborate them just by knowing the names, right? See, what have I said in the case of dynamic data memory allocation? Your memory manager, they will allocate memory dynamically to different data structures, right? The next function is dynamic address relocation. So I guess you can easily elaborate that. So here the memory manager, they can dynamically allocate the addresses which is related to a which is initially bound, connected to a relative address, and this address and the relative address to address with the relocation register, with a new register. Okay. Another function is the multiprocessor memory allocation. Now, what may be it? Suppose you have interconnection between two or more processor. The memory manager, they will adopt some kind of a allocation strategy, memory allocation strategy between these processor, so that there is no loose ends, right? So if we have two or more processors which are coupled, either tight coupled or loose coupled, so the memory manager, they will think about memory allocation schemes to share the memory between these coupled multiple processors. And the next function is memory protection to operating system functions. So this means that the system call and the function call in the user space, the system call is in the kernel or the operating system function, and the function call in the user space, these are different, and the operating system must be able to understand whether the call for resources is a system call or a function call in the user space. And if see, the operating system's function, data, heap, stack, these all are in the protected mode, and these can be accessed only with a system call, not with a function call in the user space, right? So proper protection to the memory should be ensured by your memory manager. Your operating system must be able to differentiate between the system call as well as the function call or the user call. Okay, and the final task is a memory protection among the task. So this means that a task function call, they cannot write or read into the memory space which is allotted to another task alone, which is exclusive to another task. So there must be memory protection among task also, and in fact this protection increases the memory requirement for each task, and because of which the execution time of the code of the task can also increase, because we are allocating memory space completely for a particular task, and one task cannot interfere in the memory space of another task. So our little memory manager section is responsible for all these functions. So they ensure that there is a proper use of memory address space by a process. There is a proper mechanism to share the memory space, even to restrict sharing of given memory space, exclusive memory space. And there is an optimization of the access periods of a memory by either using hierarchy of memories. So all these tasks, just in the case of a process management, the process manager is responsible for all the memory resource allocation. Similarly, in memory management, the memory manager is responsible for everything related to memory space. How to use the memory space, how to share the memory space, how to restrict the memory space, how to ensure a proper access periods between memories, everything is controlled by the memory manager, right? So I hope this session's content, which included the kernel and the services, and in the services we concentrated on process management and memory management. So the task being done in the case of both these services, I hope those are clear. So to simplify, the process management involves creating process and allocating resources to the process. And the memory management, they are concerned about who can access the memory, how can it be accessed, how can you share the memory, how can you restrict the memory. All these things related to memory comes under memory management. So I hope these are clear. Please go through it, and if you have any doubts, please let me know. In the next session, we shall discuss about device management and file management, the other services of kernel. Thank you and have a great day.